In this video, I'm going to show you how you can draw tables in Excel. So the first step would be to open up Excel. Easiest is from the Start button on your menu. However, for some of you, that's not always obvious or accessible. So if you are using OneDrive, what you can do is you can add a new Excel workbook, and that will open it on the online version of Excel. Unfortunately, the online version of Excel doesn't have all of the features that we want to use. So if you click on the editing button and click on open in the desktop app, it will open the full Excel app on your desktop. You can also use Excel at home. You just need to download the software and then log into your school account through Excel, and you should be able to have permission to use Microsoft Excel on your home devices as well. So the first thing we'll do is we'll write our table headings. This is for Planck's constant. So in Planck's constant, we'll have the wavelength, and the wavelength is recorded in nanometers. So I've written that. You'll notice, if I zoom in, you'll notice that what I've written has actually gone over the length of the cell. So if I hover my mouse in between A and B, I can actually click in that space and then drag my cell to make it wider. I'm also going to have a separate heading for my wavelength. So I'm going to write 1 over wavelength. And the units for this are going to be meters to the -1. Again, I can just expand my cell. Now I'm going to show you how you can turn that into a subscript so you've got the correct scientific notation. If you double click in the cell, you'll notice the cursor appear. And if you highlight the thing you want to make into a subscript and then hover over that and right click, go to Format Cells, this dialog box will appear and you can select Superscript, which will make the text small and appear at the top. When you click OK, you'll now see the -1 appearing how we would expect it to appear. In this practical, we're also measuring the potential difference in three different times. So I'm going to write potential difference 1, potential difference 2 with my correct units, and potential difference 3 with the correct units. I'm also going to have a column to calculate my total potential difference, average potential difference. So PD average. And again, that is measured in volts. Again, you can see that the text goes off the cell, so you can just expand the cell there. Right, the next thing is to populate this with your data. So you're going to have the wavelengths, which you've recorded in your PAG book, and you're going to have your potential differences 1, 2, and 3, which you've recorded in your PAG book. You would have also calculated, or you're likely to have calculated, your average potential difference already using your calculator in your book. However, I'm going to show you how you can use an Excel formula to calculate these averages. So first, let's input the data we have collected, and I'll show you how to use the formulae. You can now see that I've inputted all the data that I've collected so far, my raw data. So the next bit I'm going to show you is not important, but what you can do is you can just format your table, just so the headings are in bold perhaps, and you can also highlight your table and click on this icon here to access the borders and click on all borders. Sometimes that just makes it easier to see what data you're working with. So the first thing we're going to do is we're going to get Excel to calculate 1 over our wavelength. In order to start any formula in Excel, you have to press the equals button first, and we're going to do 1 divided by my wavelength. So I'm going to take 1 and then slash means divide. I'm going to select cell A2 where I've got my first wavelength. And what I'm going to do as well is I'm going to actually put brackets around A2 and convert my nanometers into meters by doing the following. So normally nanometers means times 10 to the -9. So I'm going to do times with an asterisk 10 to the power -9 and close the bracket. So this little pointy up arrow is accessed by pressing Shift and the number 6 on your keyboard. and the star can be accessed by pressing the Shift and the number 8 on your keyboard. Once the formula has been put in, make sure there are no spaces in front of your equal sign, and make sure you've got your brackets in the correct place as well. If you press the return key, you will see that this is the value that they've given you. Now, the thing with this is a really large number, which is a bit messy. In science, we prefer to use the same number of significant figures as what we've recorded. So if wavelength was recorded to 3 significant figures, then our 1 over wavelength should also be recorded to 3 significant figures. You'll also notice there's a lot of digits here, so we can just rewrite this in standard form. So the easiest way to do that is if you double click the cell, you'll notice that the formula reappears. Now what I'm going to do is I'm going to just do a little bit of maths in my head. And if I set everything to the power of 3, that makes all my answer appear as 2.1, 2, 7, 6, etc. However, what that conversion actually means is my total unit is now no longer just meters to the minus 1. It's actually times 10 to the power of 6 meters to the minus 1. And again, this 6 needs to be in a subscript. So if you right click the number 6, click on Format Cells, and you can turn that into a subscript again. And just press the return key. Right. Now the other issue I have is my significant figures. So if you go to the number section here, if you click on either of those 2 icons that you can see on the screen, by clicking on those icons, I can actually set the number of significant figures that I want. If you hover over them, it usually tells you whether it's decreasing the decimal places or whether it's increasing the decimal places. Right, so now I've got one cell which has calculated 1 divided by my wavelength, and my answer is given as times 10 to the power of 6, which is what I've written in the heading here. So now what we're going to do is we're going to replicate this formula in every single cell. The easiest way to do this is to take your mouse, place your mouse to the bottom right of the cell, which has the formula that you want, that you've just written. You'll see that the mouse has turned into a dark shaped cross. Then click on that and drag the cell down. Now what Excel will do for you is Excel will basically apply exactly the same formula. If I click on this cell, you can see that now it's being applied to cell number A3. If I click on this one, you can see that the same formula is being applied to cell number A4, so on. So this is an easy way for you to do calculations on Excel. Now to work out your averages, there is a similar function you can use. Again, start with the equal sign, type the word average, and then you want to work out an average of potential difference 1, 2, and 3. So we're going to open the bracket. With your mouse, click and highlight the cells that you want to work out an average for, and simply close the bracket. Press the return key. So now it's worked out an average. Now it's worked out an average of those 3 cells that you have highlighted. Cells C2 all the way up to E2. That's what the colon here means. It means all the cells all the way through from C2 to E2. We're going to do the same thing again. You're going to drag your mouse or move your mouse to the bottom right-hand corner of the cell, and you're going to drag it down. If for whatever reason this cell does not give you the correct number of significant figures, don't forget you can adjust the number of significant figures using the same buttons as before. So now we've got our wavelength in times 10 to the 6 meters to the minus 1 units, and we've got the average potential difference. So we are going to plot both of those things onto a graph.